Hey, what's going on guys? In this video we are going to talk about the differentiator op amplifier. For the differentiator op amplifier, you can see the capacitor is connected with the input voltage, and also we have the feedback resistance. Here we are trying to find the Vout voltage, and also we know that when we treat this one as ideal op amplifier, the current entering both sides is going to be 0, and also the voltage across the positive terminal is equal to 0 because it's connected to the ground. And for an ideal op amplifier, we assume that like voltage across the positive terminal is equal to voltage across the negative terminal. So V plus is equal to V minus. Since the V plus is 0 because this one is connected to the ground, then V minus also 0. So we have 0 voltage at this node. Okay. And also since this is 0 ampere, then the I1 must be equal to I2 because all the current, if we apply KCL right here, KCL says current entering a node should be equal to current exiting the node. So I1 is equal to I2. So we can derive our first equation, that is I1 is equal to I2. Okay. When we deal with capacitor, we find the current using this formula C dV by dt. So this is the formula for the current when we have capacitor. C dVi, because this is input voltage, so we can say C dVi by dt. And here we have this one. For this current, we can look at the voltage difference over the resistance in between. So I2 is equivalent to 0 minus VO. So we can say just minus VO divided by the resistance in between, that is RF. From this one we can create the equation. We can equate these two according to KCL. I1 is equal to I2. So we can say C dVi over dt is equivalent to negative VO over RF. Therefore VO is going to be negative RF times C dVi by dt, and this is going to be our final formula for a differentiator op amplifier. I hope this helps. Thanks for watching.